We are going to start now lecture 3 of chapter 5 class 11th mathematics, complex numbers and quadratic equations. So in this lecture we will talk about the polar representation of complex numbers. So as we have already studied in our previous classes the coordinate system, we know that if we have a point say 2, 3, we can represent that point using the x-axis and the y-axis. We are saying this is x-axis, this is the y-axis, this is called xy plane. This point it is the region O. Then we mark the points over here and correspondingly we will mark the point 2, 3. This is the point P 2, 3 we are saying. So this is the representation of any point 2, 3. Likewise we can represent any point in the form any ordered pair A, B, where A and B these are the real numbers. So if we look at the definition of a complex number, it is just like x plus iota y, where x and y these are the complex numbers. So we can just consider it like the ordered pair x, y and represent it on this plane. The change is that in case of complex number, this x-axis will be the real axis because it is corresponding to this real part of this number, and this y-axis, when we are talking about, it is the imaginary axis we can say, and it is corresponding to the corresponds to the imaginary part of the complex number. And in place of xy plane we call this as the complex plane or the argand plane. So if we give example over here, we are saying that if we have numbers, these numbers are represented over here. First is the number 3 plus 5 iota. So what we have done, we have drawn these axes, we have drawn these two axes. So these axes we are saying this is the real axis and this is the imaginary axis. We have written it is x-axis and y-axis. Now we are saying it is real axis and imaginary axis. So these points, when we are talking about 3 plus 5 iota, it is corresponding to the point A, that is 3, 5. And we know how we represent this point. We take 3 units on the x-axis, 5 units on the y-axis, and we obtain this point A 3, 5. Next is minus 4 plus 3 iota. This is the point B we are saying. Then the next point we have, it is minus 5 minus 3 iota. This is the point we are saying, minus 5 minus 3 iota. The next point we have, it is 2 minus 4 iota. This is the point 2 minus 4 iota. So these are just the point corresponding to these ordered pairs. We are saying it is 3, 5 corresponding to minus 4, 3. So as we were drawing in case of xy plane, we were drawing in place of xy plane. Similarly, we are drawing over here in the argand plane or in the complex plane. So this is a kind of representation for the complex numbers. Now in this lecture we are more interested in the polar form or the polar representation of a number. So when we are talking about the polar form, we are changing the complex number to its polar form first. So we are saying z is equal to x plus iota y. Say this is a complex number. We know that x and y these are the real numbers. So this point we have already seen that this can be represented as the point p x y in the complex plane. Now if we substitute x is equal to r cos theta and y is equal to r sin theta, if we do this substitution over here, this number will become z is equal to, r is common, we are left this cos theta plus iota sin theta. So this form is called the polar form of the complex number. This form is the polar form of the complex number, which is x plus iota y. It can be represented as z is equal to r times cos theta plus iota sin theta. Now we come to some terms over here. Before that, we are going to do some calculations. From these two equations we are saying, from these two equations, if we calculate x square plus y square, we obtain it is equal to r square. So square root of x square plus y square is equal to r, and we know that this is the value, this is the term we are already using, this is the modulus. So r is basically the modulus of the complex number. And if I divide both these terms, I will obtain tan theta, that is equal to y by x, or we can write theta is equal to tan inverse y by x. So we are saying that this theta, this is called the amplitude. This theta is called the amplitude of the complex number. And if the value of this theta, it lies between minus pi is less than theta is less than equal to pi, then it is called the principal argument or principal amplitude. When we are talking about the argument or amplitude, these are the same terms in these. This represent, we are using this term, we are using for theta. And if the value of theta lies between minus pi and pi, it is important to note over here, this point pi is included, but this minus pi is not included. So that is called the principal argument. Now we come to the polar representation. Now we are saying that we have an initial line. We are talking about, when we are talking about polar presentation, we are saying we have an initial line over here. This is the initial line. And then we are drawing a radius r. We are talking about, this is the line we have drawn, this is r. R means the length over here. This length we have drawn a line whose length is r. And the angle it is making with this initial line, we are saying this is theta. Then the point, we are not talking about this r, the r is the length. Then the point we have over here, this is the point r comma theta, where r is this length from the origin O, or the initial point O, and theta is the angle formed with the initial line in the positive direction. Then this point we are saying this will represent P r comma theta. Now in the xy plane, we were saying in xy plane this point was P x comma y. This is in the complex plane, not xy plane, it is in the complex plane. This is the point P x comma y, and it represents the complex number z is equal to x plus iota y. And in the polar plane, this is the polar plane, it is represented by r comma theta, where r represents the distance from the origin and theta represents the angle it makes in the positive direction of the initial line. So these things will be more clear to you. We have so many terms, we have introduced so many terms over here. First is polar coordinates. Second, we are talking about, it is the polar form, or we are saying modulus amplitude form. Then we have seen the definition of modulus. This r we are saying it is square root of x square plus y square, it is modulus. Then we have this theta, that we are saying it is called the argument or the amplitude, and its value is given by theta is equal to tan inverse y by x. Inverse functions you have not studied yet, but you can see it like this, that we are interested in those values of theta. We are interested in those values of theta for which tan theta is equal to y by x. This is the amplitude or the argument. It is written like this, that argument of z or amplitude of z. And if this value of theta, it lies between, the value of theta lies between minus pi and pi, where minus pi is excluded and pi is included, then this argument is called the principal argument. So these things will be more clear to you with some examples. So first case we are talking about, when z is equal to x plus iota y lies on one of the axes. So we are talking about the complex plane over here. This is the complex plane. This is the real axis. This is the imaginary axis. We are saying the number we have, either it lies on the real axis or it lies on the imaginary axis. We are talking about z is equal to x plus iota y. When it lies on the real axis, it means we are talking about the number x. And when we are talking, it lies on the imaginary axis, it means we are talking about the number iota y. So we are saying when the number lies on the real axis, it is purely real. and when it lies on the imaginary axis, it is purely imaginary. Now if we have to represent these numbers in the polar form, we are saying this is the pole we have, the initial point 0 we are talking about. This is the initial line, and corresponding to this line, if we are talking about the number, say z is equal to x, so this implies us that value of what we have substituted, we have substituted x is equal to r cos theta, we have substituted y is equal to r sin theta, we have seen the value of r is square root of x square plus y square, and we have seen that the value of tan theta is equal to y by x. So we have, first we are talking about the number z is equal to x, that is purely a real number. So in this case, the value of r that we will have, that will be equal to x, and the value of theta, we are saying tan theta will be, the value of y we have, it is 0 over x, that is equal to 0. So this implies us theta is equal to 0. It means how much distance we have to move from the initial point, it is the distance x we are saying, and what is the angle it is making with the initial line, it is 0 degree. So this is the point we are representing over here, this is the point we are saying corresponding to z is equal to x when the number is purely real. Next is when we are talking about the number, suppose I am talking about the number that is z is equal to y, in this case r is equal to y, we substitute the value over here, we get r is equal to y, and when we are talking about tan theta, we are saying the value of x we have, it is 0, so tan theta is approaching to infinity. So tan theta is approaching to infinity, so this thing means that theta is equal to pi by 2. This thing will happen when theta is equal to pi by 2. So with the initial line, we have the angle that is equal to pi by 2 in the positive direction, and the length of this vector, that will be equal to y units. So this point is representing z is equal to iota y. So this thing is mentioned over here. We are saying when z is purely real, in this case z lies on the x-axis, this case we have already seen, and if z lies on the positive side of the x-axis, then theta is equal to 0, and if z lies on the negative side of the x-axis, then theta is equal to pi. We are saying if the value of the x that we are considering, suppose the value of x we have, it is negative, we are saying say it is minus 2, then what will happen, the value of r will be equal to 2, and the value of tan theta will be equal to, it is 0 over minus 2, it is minus sign over here. It means that the value of theta will be pi, because the value of sine we have, the value of cos we have, it is, cos is negative, and the value of sine we have, it is 0. So this point will be represented by, we plot this point over here, we are saying this is the initial line, this is the initial line, and this is the angle pi. So this is the point O, and this is the point we are saying z is equal to minus 2. So we have the angle over here, it is pi. Similarly, when we are talking about the case when z is purely imaginary, then z lies on the y-axis. Again we have two cases, either z is positive or z is negative. So if it lies above the x-axis, then theta is equal to pi by 2, and if it lies below the x-axis, then theta is equal to minus pi by 2. So you can try to put different values of x and y and plot them using the polar coordinate system, or represent them in the polar form. Now the next case we have is when z is equal to x plus iota y and it does not lie on any of the axis. Now we know that we have substituted x is equal to r cos theta, we have substituted y is equal to r sin theta, We have seen r is equal to square root of x square plus y square, and tan theta is equal to y by x, that is equal to imaginary part of z over real part of z. Now we have to calculate this value. So the first step we are going to do is, we are going to calculate tan alpha is equal to, we are taking the mod over here, it is imaginary part of z over real part of z, and we calculate the corresponding value of alpha. We are calculating the value of alpha for some, this alpha will be basically an acute angle. Now we have to see in which quadrant this number is lying. We are talking about x plus iota y, in which quadrant this number is lying, and corresponding to that, using this value of alpha, corresponding to that, we will calculate the value of theta. Corresponding to that, from this x plus iota y, we will see in which quadrant this is lying. We have the value of alpha. Now we will adjust the value of alpha to obtain the corresponding value of theta in which it will lie. And we will see that this value of theta, this is basically the argument of z or the amplitude of z. So we have different cases over here. First is when z lies in the first quadrant. We are talking about how we can get the values of theta from alpha. First case we are talking about when z lies in the quadrant 1, then we are saying that theta and alpha, they are equal. Whatever value of theta we will have, the alpha we will have, same, they will be equal. We are saying the point P lies in the first quadrant, so theta and alpha, they are equal. Second case is when z lies in the second quadrant. In this case, theta will be equal to pi minus alpha. We are saying in this case, why we are getting this value? We are saying when the number z, it lies in the second quadrant, it means the value of x we have, it is negative, the value of y we have, it is positive. Now tan theta we are saying that is equal to y by x. We are saying y we have substituted, it is r sin theta, x we have substituted r cos theta. It means the value of sin theta we have, it is positive, value of cos theta we have, it is negative, and we substitute these values. So we are saying that the point P, for this point P, the angle alpha will be given by, this theta will be given by pi minus alpha. This angle will be alpha over here, and this angle theta, what is the relation between theta and alpha? We have to find the relation between theta and alpha, and this, in this case the relation is theta is equal to pi minus alpha. Why? Because when we are saying it is tan of theta, that will be equal to tan of pi minus alpha, and tan of pi minus alpha means it is minus tan alpha, and this angle pi minus alpha, it lies in the second quadrant, and this is what is required. We require the negative sign over here, and we require this angle to be in the second quadrant. Moving on to the next case, we are saying when z lies in the third quadrant. I am explaining this case over here. We are saying, suppose the point, this z we are saying it lies in this quadrant. So in this quadrant we have the number of the form minus x minus iota y. Over here the number will be of the form minus x minus iota y. It means we have cos theta is negative, sin theta is negative. We have calculated the value of alpha. We are saying alpha is basically the angle we are talking over here. It is the angle if both these values we are considering them to be positive. We have to rotate this angle in such a way, so that both these values are negative, and the final answer we obtain for tan theta, that is equal to y by x, is positive. So how we are going to do this is, we are going to write it is tan of minus pi minus alpha. If we perform this operation, clearly this minus pi minus alpha, this will lie in the third quadrant, and if we solve this value, this is minus tan of pi plus alpha, and tan of pi plus alpha, where alpha is an acute angle, we have this value is equal to minus tan of alpha, so that is equal to tan alpha. So what we are getting is that the point, it lies in the third quadrant. The value of tan we have, it is positive. The value of both sine and cos, it is negative. Similarly, for this last case, we are saying when the value in this point P, it lies in the fourth quadrant, and this value is lying in the fourth quadrant, then in this case we can see that the value of theta that we can have, the value of alpha we have already obtained. This is some angle alpha over here. If we are considering the positive values for sine theta and cos theta, now when it is lying in the fourth quadrant, so basically we have sine is negative and cos is positive. So the value of theta that we can use over here, that can be equal to minus alpha, or the value of theta we can use, that is equal to 2 pi minus alpha. So any of these two values, these are sufficient in this case. So we are saying the argument of z is equal to minus alpha or 2 pi minus alpha. So we have studied several properties related to the polar form. Now we summarize the properties that we have studied over here. So we are saying if the number z is equal to x plus iota y is there, then its polar form is r cos theta plus iota sin theta, where the value of r is basically mod of z, that is equal to square root of x square plus y square, and value of tan alpha we have, that is equal to mod of y minus x, that is equal to mod of imaginary part of z over real part of z, and corresponding to this alpha, we can calculate the values of theta, where theta lies between, when theta lies between minus pi to pi, then the answers we have is, if z lies in the first quadrant, then theta is equal to alpha. If z lies in the second quadrant, then theta is equal to pi minus alpha. When z lies in the third quadrant, the answer is minus pi minus alpha, and when it lies in the fourth quadrant, the answer is minus of alpha or 2 pi minus alpha. So these are the cases when the number, it does not lie on the axis. Then we have seen the case that when z is purely real, that is z lies on the x-axis. In this case we will have the form of argument. We are saying the arguments that we can have over here, it is either theta is equal to 0 or theta is equal to pi, and these are corresponding to the positive value of x, and this is corresponding to the negative x. Similarly, if it lies on the y-axis, we have two cases over here, that theta is equal to pi by 2 or theta is equal to minus pi by 2. So we are not talking about positive or negative numbers in case of complex numbers. So we are writing, this is when y is greater than 0. This is the case when y is less than 0. In this case, x is already we have taken equal to 0. But I am trying to say over here, when I am saying that we are not talking about positive or negative, is that if I am writing y is greater than 0, then we know that y is a real number. So I can talk about positive or negative. But we have already seen that if I am talking about iota y, then this is a complex number, and I cannot talk about iota y is greater than 0 or less than 0. We do not have these kind of properties, the ordering properties for the complex numbers. So when we are writing y is greater than 0, so basically we are saying that the imaginary part of z is greater than 0. We are not saying that z is greater than 0. This thing is wrong. Now based upon this we have certain problems over here. So first is we have to convert the following numbers in the polar form. So the first number we have it is 3. So when we are talking about the number 3, so we are saying it is z is equal to 3 plus iota 0. So if I plot this number, in place of going into calculations, I am just plotting this number. This number lies over here, it is 3. This is x-axis, y-axis. So if we are talking about this is the real axis and this is the imaginary axis. So what we can see, its distance from the origin it is 3 units. So the value of r we have it is 3. And the value of theta that we will have over here, it lies on the x-axis. So the value of theta we have over here it is 0. So we can write the polar form of this number. The polar form of the number z is equal to 3. This is equivalent to writing 3 into cos 0 plus iota sine 0, where 0 is the argument and 3 is the modulus. So if we go into the calculation part, we are saying we have the number z is equal to 3 plus iota 0. We are substituting 3 is equal to r cos theta. We are substituting 0 is equal to r sin theta. When we square and add, we get 3 is equal to r. When we divide these two values, we get tan theta is equal to 0. Both the values of sin and cos, they are positive. Sin theta, cos theta, both are positive. So the value of theta we will have it is equal to 0. So we are writing the polar form we have, that is z is equal to r cos theta plus iota sin theta. So z is equal to 3 into cos 0 plus iota sin 0. Next is to write the complex number. Z is equal to minus 5 plus 0 iota. Now if we try to plot this number lies over here, it is minus 5. So the angle it is making over here, that is equal to pi. So we are writing the value of amplitude we will have, the modulus we will have it is r is equal to 5. So its polar form will be 5 into cos pi plus iota sine pi. This is the polar form we can see from this, its representation, graphical representation. And if we come to the calculation part, we are writing it is x is equal to minus 5, that is equal to r cos theta. Y is equal to 0 is equal to r sin theta. If we square and add both these values, we get it is 5 square plus 0 square is equal to r square. So the value of r we obtain it is 5. We are taking it is positive value because it represents the length. Now the value of tan theta we have it is equal to 0 over minus 5. Clearly we have this value is negative and this sine value is positive. So we are having this is equal to 0. So we are having theta is equal to pi. So we have r is equal to 5, theta is equal to pi. And the polar form, the formula we have it is r cos theta plus iota sin theta. So if we substitute the values over here, if we substitute the value of r and theta over here, we obtain this answer. We obtain the answer that it is 5 times cos pi plus iota sin pi. Next is the number, that is z is equal to iota. So when we are writing z is equal to iota, we can write it is 0 plus 1 iota. So the value of x we have it is 0, value of y we have it is 1. We substitute x is equal to r cos theta. We substitute y is equal to r sin theta. So the value of 1 square plus 0 square is equal to r square. So this implies as the value of r is 1. R is the distance, that is why we are taking only the positive value. Now if we calculate tan theta, that will be equal to y by x and x is 0. So we get that the value of theta will approach to pi by 2. So we are writing we have obtained that theta is pi by 2 and the value of r is 1. So the polar form we have it is 1 into, that is r into cos pi by 2 plus iota sin pi by 2. Similar thing we can obtain if we plot this number graphically, we are saying that this number iota, when we are saying it lies over here, its distance from the, this is the number iota, this is the real axis, this is imaginary axis, and this distance we have, it is 1, and the angle we have over here, it is pi by 2. So the value of r we obtain, it is 1, and the value of theta we have, it is pi by 2. So by both these results we obtain that the polar form is 1 into cos of pi by 2 plus iota sine of pi by 2. Next is z is equal to minus 2 iota. So if we plot this number, this minus 2 iota will lie somewhere over here. This is minus 2 iota, this is imaginary axis, this is real axis, this is the point 0. So this distance we have, it is 2 units. And if we are talking about the angle over here, we require the angle to lie between minus pi is less than theta is less than equal to pi. So we are measuring the angle over here in the negative direction, so that will be equal to minus pi by 2. So what we get is that the value of r is 2, the value of theta is minus pi by 2. So the polar representation will be 2 cos minus pi by 2 plus iota sine minus pi by 2. So this is equal to 2 cos minus pi by 2 means it is pi by 2, and then it is minus iota sine pi by 2, because we know that cos of minus theta is cos theta and sine of minus theta is sine theta. So if we want to calculate it algebraically, we will have x is equal to 0, y is equal to minus 2. So the value of r we have, that is equal to 2 square plus 0 square root, that is equal to 2. The value of tan theta will be y by x, x is tending to 0, y is equal to minus 2. So this value is tending to minus infinity. So the value of theta we will have, it is equal to minus pi by 2. So these are the values we have. R is equal to 2 and theta is equal to minus pi by 2. Again substituting these values, we obtain this answer, and this is the polar form corresponding to this number. Next we have to find the modulus and argument of each of the complex numbers given below. So the first number that is given to us, it is z is equal to 1 plus iota. So first we try to find it graphically. We are saying this number will be somewhere over here, it is corresponding to 1 comma 1, or we are writing it as 1 plus iota. When it is real axis, this is imaginary axis, this point it is 0. So when we are talking about the argument of this number, if we join these 2 points, the length of this line will be square root of 1 square plus 1 square, that is equal to square root of 2. And the angle this line will make over here, that will be equal to pi by 4. So the modulus we have, it is root 2, and the argument we have, it is pi by 4. So this is the graphical representation. If we solve it algebraically, we will have x is equal to 1 is equal to r cos theta, y is equal to 1 is equal to r sine theta, y1 it is 1 into iota. So if we square and add both these, it is x square plus y square is equal to 1 square plus 1 square is equal to r square. So the value of r square we have 2, so this implies us r is equal to square root of 2. Next we have to calculate is the amplitude, so we are dividing both these equations. We get it is tan theta is equal to 1. Both sine and cos, they are positive. It means the values will lie in the first quadrant. For first quadrant, the value of tan theta is 1. So this implies us theta is equal to pi by 4. So this is the r is equal to root 2 is the amplitude, and theta is equal to pi by 4 is the modulus, and this is the amplitude or the argument. And if we have to write the polar form of this number, so that will be square root 2 into cos pi by 4 plus iota sine pi by 4. Next is the next number that is given to us, it is minus root 3 plus iota. So we have this is equal to x plus iota y. So we are saying x is equal to minus root 3, y is equal to 1. So we are substituting x is equal to r cos theta, y is equal to r sin theta. We have cos theta is negative, sin theta is positive. So the number, this number we are talking about, it lies in the second quadrant. We are saying sin is positive, cos is negative, so the number is lying in the second quadrant. So first of all, we are calculating the value of r. So we are squaring and adding these values. It is x square plus y square is equal to minus root 3 square plus 1 square, and that is equal to r square. So we get 3 plus 1 is equal to r square. So this implies us the value of r we have, it is equal to 2. Next is we have to calculate the value of argument. So to calculate the value of argument, first of all we are calculating tan alpha is equal to mod of y by x, that is equal to 1 by root 3. So this implies us that the value of alpha is pi by 6. So we are saying the value of alpha is pi by 6 means now we have to use this to find the value of theta. And we have already seen that this number we are talking about, it lies in the second quadrant. So based upon the formula that we have already studied, we are saying the value of theta will be, or we are saying argument of z, that will be theta, that is equal to pi minus alpha. So that will be equal to pi minus pi by 6, that is equal to 5 pi by 6. So if we have to write the polar form of this number, the polar form of this number will be 2 times, it is r is equal to 2, cos of 5 pi by 6 plus iota sine 5 pi by 6. And clearly this value 5 pi by 6, it lies between minus pi is less than 5 pi by 6 is less than equal to pi. So this is the principal value we are talking over here. Next is the number minus 1 minus iota root 3. So we are saying z is equal to minus 1 minus iota root 3. This is equal to x plus iota y. So we have x is equal to minus 1, y is equal to minus root 3. So we are going to substitute now x is equal to r cos theta, r sin theta. Both cos and sin, they are negative. It means that this number we are saying, this lies in the third quadrant. This thing we can also see over here, that if we plot the number minus 1 minus root 3, so that number will lie somewhere over here in the third quadrant. So first of all we have to calculate now is the value of r. So that will be root 3 minus root 3 square plus 1 minus 1 square square root. So that will be equal to 3 plus 1 square root, that is equal to 2. Next we have to calculate is tan alpha, that is mod of y by x, that is equal to root 3 by minus root 3 by minus 1, that is equal to root 3 by 1. So we get that the value of alpha is pi by 3. We are calculating the acute value alpha over here. Now based upon our formula that we have already seen, the value, this number is lying in the third quadrant, value of alpha is pi by 3. So whatever formula is saying that the argument of z, that is equal to theta, that will be equal to alpha minus pi. So the answer we will obtain, it is pi by 3 minus pi, that is equal to minus 2 pi by 3. So what we have obtained over here is that the value of r means we are talking about modulus we have, that is equal to 2, and the value of argument of z that we have, it is minus 2 pi by 3. So if we have to write the polar form, so that will be 2 cos minus 2 pi by 3 plus iota sine minus 2 pi by 3. So that will be equal to 2 cos 2 pi by 3 minus iota sine 2 pi by 3. So this is the polar form corresponding to this number. Next is we have to convert this number 1 plus iota root 3 into the polar form. So again we are writing x plus iota y is equal to 1 plus iota root 3. So we have x is equal to 1, y is equal to root 3, we have r is equal to 2. When we square these terms, how we are getting this value? It is root 3 square plus 1 square and whole square root. So the answer we obtained is 2. The value of tan theta we will have, it is root 3 by 1. So the value of theta we will have, that is equal to pi by 3. Why we are directly calculating tan theta over here? Because both these values, these are positive, and in this case we know that alpha is equal to theta. It lies in the first quadrant. So alpha is equal to theta. So we get the value of theta is equal to pi by 3. So the polar form we will obtain, it is r is 2 cos pi by 3 plus iota sin pi by 3. This is the number 1 plus iota root 3. This is equal to this value. This is the polar form of this number. Next is the number 2 root 3 minus 2 iota. Suppose we are writing it is equal to x plus iota y. So the value of x we have, it is 2 root 3. We are substituting it is equal to r cos theta. We have y is equal to minus 2, that is equal to r sin theta. The number lies between this number we are talking about, this lies in the fourth quadrant. This number lies in the fourth quadrant. Cos is positive, sin is negative. You can see from this, or from here you can see that we are talking about the number 2 root 3 comma minus 2, and clearly this number lies in the fourth quadrant. So the first thing we have to calculate over here, it is the value of r. So that is equal to square root of 2 root 3 square plus minus 2 square. So that is equal to square root of 12 plus 4, that is equal to 16, and this comes out to be equal to 4. Next thing we have to calculate now, it is tan alpha is equal to mod of y by x, that is equal to mod of minus 2 by 2 root 3. This is equal to 1 by root 3. So the value of alpha we obtain, that is equal to pi by 6. Now the number, it lies in the fourth quadrant. The value of alpha we have, it is pi by 6. So the value of theta we will have, that is equal to minus alpha is equal to minus pi by 6. So the polar form of this number will be r is 4 into cos of minus pi by 6 plus iota sine of minus pi by 6. This is equal to 4 times cos pi by 6 minus iota sine pi by 6. So this is our final answer. This is the polar form of this number. Next is, this number is given, we have to convert it into the polar form. So it is minus 2 plus 2 iota root 3, we are substituting it is equal to x plus iota y. So we get x is equal to minus 2 is equal to r cos theta, y is equal to 2 root 3 is equal to r sin theta. This number, this is corresponding to minus 2 comma 2 root 3, or we are saying cos is negative, sin is positive. It means this number, it lies in the second quadrant. So if we calculate the value of r, we are having it is 2 minus 2 square plus 2 root 3 square root. So it is equal to square root of 4 plus 12, that is equal to 4. Next we have to calculate is tan alpha, that is equal to mod of y by x, that is equal to 2 root 3 by minus 2, that is equal to root 3. So the value of alpha we will have, that is equal to pi by 3. Now look at these values over here. It lies, this number, it lies in the second quadrant. Alpha is equal to pi by 3. and we know that the value of theta will be given by pi minus alpha. This will be equal to argument of z. So that will be equal to pi minus pi by 3, that is equal to 2 pi by 3, and this value, it clearly lies between minus pi is less than this value is less than equal to pi. So the polar form of this number will be 4. The value of r we have, it is equal to 4 into cos of 2 pi by 3 plus iota sine of 2 pi by 3. So this is the polar form of this number, that is minus 2 plus 2 iota root 3. Next is to convert this number in the polar form. So first of all, we are converting this number to the standard form. The number we have, it is 1 plus 7 iota over 2 minus iota square. So we can write it is 1 plus 7 iota over, when we open the whole square over here, we will get it is 4 minus 1 minus 4 iota, minus 1 because it is iota square, that is equal to minus 1. So it is 1 plus 7 iota over 3 minus 4 iota. So to simplify this, we are doing 3 plus 4 iota multiplying and divided with 3 plus 4 iota. So the answer we get, it is equal to 3 plus 4 iota plus 21 iota minus 28 divided by 9 plus 16. So this answer comes out to be equal to minus 25 plus 25 iota divided by 25, and this is equal to minus 1 plus iota. Now if we look at this number, this lies in the second quadrant. The value of r we will have, it is minus 1 square plus 1 square square root, that is equal to root 2. The value of tan alpha we will have, that is equal to 1 mod of 1 by 1, that is equal to 1. So this implies as alpha is equal to pi by 4. The value of theta, as this value is lying in the second quadrant, so the value of theta will be equal to pi minus alpha, so that is equal to pi minus pi by 4, that is equal to 3 pi by 4. So the polar form of the given number, that will be square root 2 into cos of 3 pi by 4 plus iota sine of 3 pi by 4. Next is 1 over 1 plus iota. So we simplify this number in this way. We multiply and divide with 1 minus iota. We get it is 1 minus iota over 1 plus 1. So the number becomes 1 by 2 minus 1 by 2 iota. Now, corresponding to this number, the value of r that we will have, that will be square root of 1 by 2 square plus 1 by 2 square. So that will be equal to, this value is 1 by 4 plus 1 by 4. So that is 1 by 2. So it is 1 by root 2. And the value of the number, if we look at this number will lie in the fourth quadrant. So if we calculate the value of tan alpha, that will be mod of minus 1 by 2 by 1 by 2, that is equal to 1. So the value of alpha we will obtain, that is equal to pi by 4. So the value of theta we will have, that will be equal to minus pi by 4, because this number, it is lying in the fourth quadrant. So what we obtain is the polar form of this number will be 1 by root 2, the value of r we have over here, into cos of minus pi by 4 plus iota sine of minus pi by 4. Cos of minus pi by 4 we have, it is cos of pi by 4, and this is minus iota sine pi by 4. So this is the polar form of this number. Next we are given this number. It is iota minus 1 divided by cos pi by 3 plus iota sine pi by 3. So if we look at this number cos pi by 3, the value we know it is 1 by 2. The value of sin pi by 3, it is root 3 by 2. So we can write this number in the form, if we take the LCM over here, the denominator part will become 1 plus iota root 3 by 2. So it is iota minus 1 into 2 divided by 1 plus iota root 3. To simplify this number, we are multiplying it with 1 minus iota root 3, dividing it with 1 minus iota root 3. So this is equal to 2 times, if we multiply these values, it is iota minus 1, then it is plus root 3 plus iota root 3 divided by, if we multiply these values, it is 1 plus 3 we have. So this value, this will become 4, this gets cancelled and we are left with 2. So the number we obtain, it is in the form, this is the value we are saying, root 3 minus 1 by 2 plus root 3 plus 1 by 2 times iota. So this is the number we are obtaining over here. This number that is given to us, it is equivalent to this number. For solving these kind of questions, we will see another method using the Euler's form, but right now we solve it in this way. So we are saying that from this number, the value of r will be, the value of r that we will have, it will be equal to root 3 plus 1 by 2 square plus root 3 plus 1 by 2 square minus 1 by 2 square root. On solving this value, you will obtain the value of r is equal to square root 2. Next, we have to calculate the angle. So we are writing tan alpha is equal to mod of imaginary part of z over real part of z. So we have shown these calculations over here. We are writing it is real imaginary part of z into real part of z. We obtain the number in this form. On simplifying these terms, we obtain the number like this. So we can see the value 1 it is 10 pi by 4. The value 1 by root 3 it is 10 pi by 6. So we are obtaining the answer in this way. And this is the formula of tan of pi by 4 plus pi by 6. And this is equal to tan of 5 pi by 12. So the value of alpha we have, that is equal to 5 pi by 12. Now the next thing we have to see is in which quadrant this number lies. So if we look at these values over here, we are saying it is this value, look at this value, it is root 3 is 1.732 minus 1 by 2. So this number will be positive, this number will be positive. It means this whole number we are talking about, this z is equal to this whole number, this lies in the first quadrant. So if this lies in the first quadrant, so what is that is the value of argument of z, that is equal to theta, that will be equal to alpha, and the value of alpha we have obtained, it is 5 pi by 12. So we have the value of r is square root 2, the value of alpha, that is theta, is 5 pi by 12. So its polar form is root 2 into cos of 5 pi by 12 plus iota sine 5 pi by 12. Apart from this, I am going to just introduce you a new procedure, that the details of that we will do in our next lectures. So the number we have, it is iota minus 1 over cos pi by 3 plus iota sine pi by 3. We will see further that this number r cos theta plus iota sine theta, we can write this in the form r e raised to the power iota theta. This is called the Euler form. We will see the details in our next lectures. Right now you can just look at what is going to happen over here, why we are using this kind of form. So if I talk about this numerator part, we can see it is iota minus 1 or we are writing it is minus 1 plus iota. So the polar form for this number, the value of r for this number, that will be equal to root 2, and the value of theta for this number, that will be equal to this number. This will lie in the second quadrant. The value of tan alpha is equal to 1. So this implies as alpha is equal to pi by 4. So the value of theta we will have it is pi minus pi by 4, that is equal to 3 pi by 4. So the polar form for this number, that will be root 2 e raised to the power iota 3 pi by 4. And the polar form for this denominator part, if we write the value of r, we have it is 1. So it is 1 e raised to the power iota pi by 3. So if we divide both these numbers, we will get it is root 2 e raised to the power iota 3 pi by 4 divided by e raised to the power iota pi by 3. We will obtain this is equal to root 2 e raised to the power iota 3 pi by 4 minus pi by 3. So that is equal to root 2 e raised to the power iota 5 pi by 3. And this is equal to root 2, again using this formula over here. We get it is cos of 5 pi by, this is pi by 12 over here, plus iota sine 5 pi by 12. So this is the same answer we are obtaining. So we will see this form, this Euler form in our next lectures. With this kind of formula, this question will be simplified. So right now you can try to solve it using this detailed procedure, and after we will study this Euler's form, you will come to know how this question can be solved in this way. Next is the number minus 1 minus iota, and we have to express it in the polar form. So we are having x is equal to, have over here, x is equal to minus 1 and y is equal to minus 1. So the value of r we have it is square root of minus 1 square plus minus 1 square. So that is equal to root 2, and the value of tan alpha we will have, that is equal to 1. So this implies us alpha is equal to pi by 4. Now looking at this number, clearly this number lies in the third quadrant. This number lies in the third quadrant. So we get that the value of theta we will have, that is equal to minus of pi minus alpha. So that is equal to minus of pi minus pi by 4. So this is equal to minus 3 pi by 4. So the polar form of this number, that will be root 2 cos of 3 pi by 4 minus iota sine 3 pi by 4. Next is the number minus root 3 minus iota. So in this case we have the value of x is equal to minus root 3, we have value of y is equal to minus 1. Now the value of r we have it is minus root 3 square plus minus 1 square root. So that comes out to be equal to 2. The value of tan alpha we will have, that is equal to minus 1 by minus root 3 mod, that is equal to 1 by root 3. So the value of alpha we get, that is equal to pi by 6. Again this number, this lies in the third quadrant. This number, it lies in the third quadrant. So the value of theta we will have it is minus of pi minus pi by 6. So that will be equal to minus 5 pi by 6. So the polar form of this number, it is the value of r we have it is 2, the value of theta we have, this is minus 5 pi by 6. So polar form we have it is 2 cos 5 pi by 6 minus iota sine 5 pi by 6. So I hope this is clear to you why we are writing this plus sign over here and minus sign over here, because when we are talking about cos of minus 5 pi by 6, that is equal to cos 5 pi by 6, and when we are talking about sine of minus 5 pi by 6, we have the answer as minus sine of 5 pi by 6, and this is why the negative sign is there and positive sign is there. Next is the number, it is 1 plus 2 iota over 1 minus 3 iota. So we write it in the standard form. So we are multiplying it with 1 plus 3 iota, we divide it with 1 plus 3 iota. The answer we obtain, it is 1 plus 3 iota plus 2 iota minus 6 divided by 1 plus 3 square. So this is equal to when we calculate this value, the answer you will get it is minus 5 plus 5 iota by 10. So this is equal to minus 1 by 2 plus 1 by 2 iota. So this number lies in the second quadrant. The value of r that we will have, it is square root of minus 1 by 2 square plus 1 by 2 square. So the answer comes out to be, this is 1 by 4 plus 1 by 4, that is equal to 1 by 2. So the answer comes out to be 1 by square root of 2. And the value of theta, when we are talking about, so we calculate tan alpha. So that is equal to mod of 1 by 2 minus 1 by 2, so that is equal to 1. So this implies us that the value of alpha we have, it is equal to pi by 4. Value of alpha we have, it is pi by 4. So the value of theta, it lies in the second quadrant. So the value of theta we will have, it is pi minus alpha, that is equal to pi minus pi by 4, that is equal to 3 pi by 4. So the polar form we have, the value of r we have, it is 1 by root 2, and the value of theta we have, it is 3 pi by 4. So it is cos 3 pi by 4 plus iota sine 3 pi by 4. So we get this answer. Next is express this number in the polar form. So we have the number, it is sine of pi by 5 plus iota 1 minus cos of pi by 5. So if we calculate the value of r, first thing is, this is not in the form polar form, because the polar form is r into cos theta plus iota sine theta. Over here we are not having the term sine theta. So to calculate the value of r, we are writing this value is x and this value we have, it is y. So the value of r we have, it is square root of sine pi by 5 square plus 1 minus cos pi by 5 square. So this is equal to square root of sine square pi by 5 plus 1 plus cos square pi by 5 minus 2 cos pi by 5. This value, sum of sine square pi by 5 plus cos square pi by 5, this is equal to 1. So we get it is equal to root 2 minus 2 cos pi by 5. So this is equal to, this is the value of r we are saying. So this is equal to square root of 2 into 1 minus cos pi by 5, and this is equal to square root of 4 sine square pi by 10, and this is equal to 2 sine pi by 10. So we have obtained the value of r as 2 times sine of pi by 10. Next thing we have to calculate over here, it is tan of alpha. So that will be equal to 1 minus cos pi by 5 divided by sine pi by 5. So again, applying the formula for half angles, we will have it is 2 sine square pi by 10 divided by 2 sine pi by 10 cos pi by 10. This 2 and 2 get cancelled, sine get cancelled, and we are left with this tan pi by 10. So the value of alpha we get, that is equal to pi by 10. Now coming back to this question again, we can see that the value of sine pi by 5, this will be always positive. And when we are calculating 1 minus cos pi by 5, value of cos pi by 5 will be always less than 1. So this whole value will be positive. It means this whole number, when we are talking about, it will lie in the first quadrant, because both x and y, they are greater than 0. So it means that the value of alpha is equal to pi by 10 is equal to value theta. So the value of r we have, it is equal to 2 sine pi by 10, and the value of theta we have, that is equal to pi by 10. So the polar form of this number will become 2 sine pi by 10 into cos pi by 10 plus iota sine pi by 10. So, this is the polar form of this number. Next is convert this number in Cartesian form. Now, it is a converse question. We are having 4 into cos 300 plus iota sine 300. So, we have to convert it into the Cartesian form. Cartesian form means we are talking about we have to write it in the form x plus iota y. So, we are writing it is 4 times cos of 300, we can write it is 360 minus 60, and this value we are saying it is 360 minus 60. So, this is equal to 4 times. When we are talking about this value, this lies in the fourth quadrant. This value, it lies in the fourth quadrant. So, the answer we get it is equal to cos of 60 minus iota sine of 60. So, this is equal to 4 times 1 by 2 plus iota, this is not plus iota, it is minus iota root 3 by 2. So, the answer we obtain, that is equal to 2 minus 2 iota root 3. So, this number now it is in the form x plus iota y, which is required Cartesian form of this number. Next is we have certain proofs related to arguments of the complex numbers. So, first we are talking about that for any complex numbers, we are having the complex number z, z1 and z2. The first thing we are going to prove is that argument of conjugate of z, that is equal to minus argument of z. So, if we look at this result graphically, we are saying that if the number z, it lies over here, we are talking about this is the number z, we know that the conjugate of z means we are taking its image along the x axis. So, if this angle is theta, so this angle will be minus theta. Suppose this number it lies over here, we are taking the image about the x axis. So, if this whole angle we are talking about, and we are talking about this angle over here. So, these are the angles we are talking about, and we have to prove that argument of z bar, that is equal to minus argument of z. So, to prove this result, we are writing z is equal to r cos theta plus iota sin theta, where we are saying mod of z is equal to r and argument of z is theta. So, we are writing this number in the form z is equal to r cos theta plus iota r sin theta. Now, if we take the conjugate of both these numbers, we will obtain z bar is equal to r cos theta. This is just a real number. When we are talking about this number r cos theta, it is just a real number, and it will become minus iota r sin theta. This is equal to r cos of minus theta plus iota r sin of minus theta. What we have done? We have shifted this minus sign over here, and we know that sine of minus theta is equal to minus sin theta, cos of minus theta is equal to cos theta. So, this gives us, this is equal to r into cos of minus theta plus iota sine of minus theta, and this thing proves that the argument of z bar, it is equal to minus of theta. This thing proves that the argument of z bar is minus theta, and minus theta means it is minus argument of z. Next result we have to prove is that argument of z1 z2, that is equal to argument of z1 plus argument of z2. So, again we are considering two numbers over here. One is z1 is equal to r1 cos theta 1 plus iota sin theta 1, and z2 is equal to r2 cos of theta 2 plus iota sin theta 2. Now, if we are talking about the argument of z1 into z2, it means we have to calculate the value of z1 into z2. So, if we multiply both these numbers, the answer we will obtain, it is we are multiplying both these terms. So the answer we will get it is r1 r2 into cos of theta 1 plus theta 2. This term is there. Then it is plus iota sine of theta 1 plus theta 2. Why we are getting these values? When you multiply these numbers, you will get it is r1 r2 cos theta 1 cos theta 2, and then you will get it is minus r1 r2 sin theta 1 sin theta 2. We are talking about the multiplication of this term iota sin theta 1 iota sin theta 2. So value of iota square will be minus 1. So this term will become minus 1. So if we take r1 r2 common, we are left with this cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, and this is the formula for cos of theta 1 plus theta 2. So we are writing this is equal to, if we look at this value, we are saying z1 z2 is equal to r1 r2 into this. Now this part r1 r2, this gives us the modulus of z1 z2, and this value we are talking about is theta 1 plus theta 2, this gives us the argument of z1 z2. So what we are getting over here, that argument of z1 z2, that is equal to theta 1 plus theta 2, that is equal to argument of z1 plus argument of z2. So this is the final answer that we have obtained, that argument of z1 z2 is equal to argument of z1 plus argument of z2. Similarly, in the next part we are going to prove that argument of z1 z2 bar, that will be equal to argument of z1 minus argument of z2. An easy way to prove this result is, we are using this result, we are having the result that argument of z1 z2, that is equal to argument of z1 plus argument of z2. We are having another result that argument of z2 bar, that will be equal to minus argument of z2. So in this first formula, if we replace z2 by z2 bar, we get z2 bar over here, and by using this second result, we obtain that argument of z1 z2 bar, that is equal to argument of z1, we are using this value over here, minus argument of z2, and this is what we have to prove. So this is an easy way to prove this result. Otherwise, what you have to do, you are going to write z1, you are going to write the value of z2. After that, you will calculate the value of z2 bar. You are going to write the value of z2 bar. So the value of z2 bar we have, it is r2 cos theta 2 minus iota r2 sin theta 2. Then you will multiply the value of z1 and z2 bar. When you multiply z1 and z2 bar, you will obtain the answer in this form. And this thing proves this result, that argument of z1 z2 bar is equal to argument of z1 minus argument of z2. Otherwise, we are directly using this result to prove over here. Now in the last part, we have to prove that argument of z1 by z2 is equal to argument of z1 minus argument of z2. So if we look at the polar representation of 1 by z2, suppose we are saying that we are having z2 is equal to r cos theta 2, this is r2 into cos theta 2 plus iota sin theta 2. So 1 over z2 will be 1 over r2 into 1 over cos theta 2 plus iota sin theta 2. Now if we multiply and divide it with cos theta 2 minus iota sin theta 2 and divide it with cos theta 2 minus iota sin theta 2, we multiply both these terms, the answer we obtain it is cos square theta 2 plus sin square theta 2, and this denominator it will become 1. So what we are getting, that value of 1 by z is basically 1 by r2 into cos theta 2 minus iota sin theta 2. So in this problem we are going to solve it is z1 into 1 by z2. So that will be equal to r1 by r2 into cos theta 1 plus iota sin theta 1 into cos theta 2 minus iota sin theta 2. When we multiply these terms, we are getting it is r1 by r2 into, when we will multiply this term, it is cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. We will have sin theta 2 over here, and then we will have plus iota into sin theta 1 cos theta 2 minus sin theta 1 sin theta 2 cos theta 1, and these values we are talking about. This is the formula for cos of theta 1 minus theta 2, and this second term sin theta 1 cos theta 1 minus sin theta 2 cos theta 2, this is formula for sin of theta 1 minus theta 2. So from both these results, what we get is that argument of z1 by z2, that is equal to theta 1 minus theta 2. Look at this term we are talking about. This is z1 by z2 and this is equal to this value. So what is the amplitude over here? Amplitude over here, it is theta 1 minus theta 2. So we are writing that argument of z1 by z2 is theta 1 minus theta 2, that is equal to argument of z1 minus argument of z2. Next we have is, if z1 and z2 are conjugate to each other, then we have to find the principal argument of minus z1 z2. Now it is being given that z1 and z2, these are conjugate to each other. It means z1 is equal to z2 bar, or we are saying z2 is equal to z1 bar, because they are conjugate of each other. So we have to find the principal argument of minus of z1 into z2. So if we are talking about z1 into z2, that will be equal to z1 into z1 bar, and this is equal to mod of z1 square. This is equal to mod of z1 square. And if we look at the sign over here, it is minus of z1 z2 we are talking about. That will be equal to minus of this, and this will be equal to minus of this. Look at this term over here. This is mod of z1 square. This number when we are talking about mod of z1 square, this is a real number and it is positive. And because of this minus sign, this whole number over here, this whole number we are saying, this will be a negative real number. Now if it is a negative real number, it means the argument of this number will be, the argument of a negative real number is always pi. We are talking about the principal argument. Principal argument means we are talking about minus pi is less than theta is less than equal to pi. So we are saying that the principal argument over here, that will be equal to pi, because minus z1 into z2, this is a negative real number. Next is, let z be a non-zero complex number, then find the value of argument of z plus argument of z conjugate. So we know that argument of z, that is equal to minus argument of z conjugate. So this thing implies us that argument of z plus argument of z conjugate, that is equal to 0. Another way to solve this is, we are talking about argument of z plus argument of z conjugate. So that is basically we are saying argument of z into z conjugate, and we are adding these two values. We are saying this is equal to product. So this is equal to argument of mod of z square. Now this mod of z square, when we are saying this is a positive real number for z not equal to 0, because z is given to be a non-zero complex number. So it is a positive real number, and for positive real numbers the value of argument is always 0. This thing we have already seen, that if we plot the positive real numbers, they will lie over here on the positive on this side of the imaginary axis, and the value of theta over here, it is equal to 0. That is, the argument of these numbers is equal to 0.